Good morning, good afternoon, and good evening. Welcome to the Crazy Hat Chemist. So here's another video here, and this is a new unit here. This is going to be atomic structure and nuclear chemistry. So we've already done a atomic structure unit, but this is going to be an add-on, if you will, and we're going to have to go back in time just a little bit, do a little bit of review of atomic structure, and add into that as well as do some nuclear chemistry. So just some basic atomic structure here to begin with. And what do you need? Well, you most certainly need a periodic table. So what is this? This video is Atomic Structure Worksheet General Chemistry, Roman numeral 1. And we've done one of these tables here before. We're going to fill in the following table based on the assumption that all elements are neutral. All right. So we've done ions before, but this one does not have ions. This is just more of a review of anything here. So we have certain parts that are given in this table, and I'm going to highlight the sections that are given. And then from those given sections, then we should be able to fill in the remaining bits of sections here. All right. So what do you need? You most certainly need a periodic table, and that is right here. So I've got one right here for us, a periodic table. So make sure that you have a periodic table handy. You should probably actually already watch my previous videos on atomic structure. That would be most certainly appropriate as well. All right. So without further ado, let's get started on this here, and let's see what we can hammer out on this video. All right, perfect. All right, so we've got a few highlighters here to make us happy and delightful. All right, so this first one, it says gold 198. So this 198, what does this represent? This represents the mass, okay? So you do need to know that. That is the mass. Okay, and then we also have this symbolic notation, the AXZ, this AXZ right over here. Okay, the A is representing the mass. The Z is the atomic number. And the X is the symbol of that element. Okay, so A, X, Z. The A is the mass. The Z is the atomic number. And the mass is equal to the sum of the protons and the neutrons. The atomic number is equal to the number of protons. And in a neutral element, it is also equal to the number of electrons. So that's why I'm going to do that in a different color right there. And this X is the symbol of the element, and that can either be a capital letter or a capital and then followed by a lowercase letter. All right, so let's see if we can move on forward here. So this 198 is representing the atomic mass, and so that would be 198 right there for gold. Now we need to find gold on our periodic table. It has a mass that's approximately 198. It might not equal 198 exactly, but here it is. I will highlight it here. It has an average mass of 196.97. It has there it is, it's gold. It has a symbol of a capital A followed by a lowercase u, and then it is atomic number 79. So we're going to copy some of this information here. So the symbol is an capital A, a lowercase u. So it's a capital A, lowercase u. The mass is 198. So that's 198. And then the atomic number right here is 79. There it is. That is 79. All right. So we have the mass as 198. That is the sum of the protons and the neutrons. The atomic number is 79. That is the Z in our symbolic notation. So the atomic number is 79. The number of protons and the atomic number are one in the same. So that's also 79. And then while we're at it, the number of protons and the number of electrons are the same in a neutral atom. So that's the key here, is that in a neutral atom, the protons and electrons are equal to each other. So that means we have 79 electrons as well. In order to get the neutrons is the mass, which has the sum of the protons and neutrons, and then we have the number of protons. So if we subtract the 79 from that 198, then we should be able to get the number of neutrons, and that is 119 in this particular isotope of this element. Okay. All right. Hopefully that was our first one. That worked out pretty well. Now what we're going to do is we're going to do our second row here, second period. You should see that 204 is the mass. So I'm going to write that right here. 204, that's the mass. This 82 is the atomic number. The atomic number is equal to the number of protons. That's why it's 82 protons. And since we are dealing with the neutral element, the number of protons is equal to the number of electrons. That's also 82. All right, now we're going to take the difference between the 204 and the 82, and that will give us 122. That is the number of neutrons right there. All right, now we're going to use this symbolic notation and then write out the name of this element. Now, we're not looking for a search out there on the periodic table world of the 118 elements that are out there. We just need to find element number 82. So 82 is the element that we are looking for. So the periodic table is organized according to atomic number. That is the primary principal organization of the periodic table, and it goes by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and there is number 82. It has the symbol of PB, and that is corresponding with this PB that we have right here as well. So that should correspond. What is the element name? It is a lead, right? So lead, LEAD, and the mass of this particular isotope is 204, so this is lead 204. Now, I'm going to highlight something here in pink with lead, and that is 207.2, as well as this 196.97 for the gold. The underlined or the highlighted in pink here of the lead and the gold, these are the average atomic masses of all the naturally occurring isotopes. So that's not what we're focusing on right now. This is a particular isotope. It has a whole number for its mass. So in a little bit, we'll be talking about this number right here and how to arrive and derive this number right here, the 207.2, but not at this moment in time. All right. We will be covering that on the second half of this worksheet. So the next thing is the atomic mass is 124. The atomic number is 50. So if the atomic number is 50, then the number of protons is 50. If this is a neutral atom, which we are assuming that, then the number of electrons is also 50. The difference between the atomic mass, which is again the sum of the neutrons and the protons, that is the 124 minus the 50, and I will get the 74 neutrons. I'm going to look up number 50 on our periodic table, and that will tell me what element this is. And so I'm going to find element number 50. Element number 50 is right here, and that is 10, and it has a symbol of SN. So element 50, SN for the symbol, and 10. So that means 10, Tin, a dash, and then the mass, which is 124. And then the symbol is SN. It's a capital S, a lowercase n, make sure of that. The mass is 124, and the atomic number is 50. All right, perfect. We're filling in all the spots here. The next one here, in this next horizontal section, we have protons at 19. So that means that in a neutral atom, the number of protons and the number of electrons are the same, and you should see that that is consistent here. So this is 19. 19 for the number of protons is also equal to the atomic number, which is 19. Now, to get the atomic mass, we're going to take the sum of the protons and the neutrons. So we're going to add these up. So we're going to take our 19 and our 22 that we have right here. That will equal 41. That is our mass. So we can partially fill in our symbolic notation right here. Our mass is 41, okay, and it will be a dash 41 of whatever that element name is. And the atomic number is 19, so that's 19 right there. So I'm going to look up on our periodic table, atomic number 19. That would be right over here. Atomic number 19, that is a symbol of a K, and it is potassium. So I'm going to write the symbol for that is a capital K, and it's potassium. Potassium dash 41. Perfect. That's looking great so far. Going to highlight one more thing here, and potassium's average atomic mass of all the naturally occurring isotopes is 39.10. We'll be discussing that in the latter half of this. The next one here, next horizontal section, we have 35 electrons, and that would correspond to 35 protons. And of course, the protons and the atomic number are equal, so that's 35 protons and 35 for the atomic number. The mass is the sum of the protons and the neutrons, so we're going to take our 35 and our 47 and sum them up. That will be 82. Okay. And then we are going to look on our periodic table, and we're going to find element number 35. Where is number 35? Let's see if we can find that. It's right here. Here is element number 35. It is capital B, lowercase r, and that is for bromine. So bromine dash, and it is a capital B, lowercase r. The mass is 82. That's the sum of the protons and the neutrons. The atomic number is 35. It is called bromine 82. Okay. All right, next one. Well, we have the number of protons and the number of neutrons. So we're going to sum these two numbers up. That's 63 plus the 92. That's going to equal 155. That's the atomic mass. The atomic number and the number of protons, 63. They are the same. The number of protons and the number of electrons, since it's a neutral element, that's 63. That will be the same. The mass is a 155. The atomic number is 63. So we're going to have to find 63 on our periodic table. That is way down over here. 63, that is EU for europium. That would be EU and europium. Dash 155. Okay, fantastic. That's looking great. I love that. All right, so we have done the first two of this worksheet here, and so we need a little note from our sponsor. Our sponsor for today's video, as in all my videos thus far, until I get an official real sponsor, and that is the sponsor for this video is the Crazy Hat Chemist, and I'd greatly appreciate if you take a moment of your time, if you are actually learning any chemistry, which I hope you are. If you're paying attention, then you're going to subscribe to my YouTube channel, and you're going to give me a thumbs up. You're going to comment, and you're going to pass this videos and all my videos on to all of your friends in your chemistry classes so that they can learn chemistry as well. All right, please do that. I'd greatly appreciate that. All right, so now what we're going to do is we're going to do the second half of this worksheet here. The second half of this worksheet is right here with the next problem, which is problem number 1. It says there are 3 stable naturally occurring isotopes of potassium, which have masses of 30, I'm going to highlight some of this here, 39 atomic mass units, 40 atomic mass units, and 41 atomic mass units. Their percent abundances are 93%, 1%, and 6% respectively. I'm going to highlight that word respectively. Okay. Respectively. All right, perfect. When that word respectively means that this 39 is with the 93, and this 40 is with this 1, and this 41 is with this 6. That means that the order of which you had before is the same order that you have later on. From the following, that information, calculate the average atomic mass. So we're going to calculate the average atomic mass of potassium and compare that calculated value with what's on the periodic table. All right. So what is our equation? So here is our equation. The average, that's X bar, is equal to percent times mass plus percent times mass plus percent times mass. The reason why we have three of these, that's 1, 2, and 3, is that we have actually three isotopes. We have an isotope of 39 atomic mass units, 40 atomic mass units, and 41 atomic mass units. So we are going to calculate the average. That's X bar is equal to the percent is 93. So I'm going to highlight this in colors here. I used a black pen, so 93%. So 93%. And 93% is 93, really 93 divided by 100. So we're going to say 93 over 100. Okay, that will give me my decimal value. Its mass is 39 atomic mass units. Okay, plus the next one I asterisked in red, it's 1%. So that would be 1 divided by 100 times the 40 atomic mass units. The next one I highlighted in blue, and that would be 6%. So that's 6 divided by 100 times the 41 atomic mass units, just like that. All right, so what we're going to do is we're going to plug all this into our calculator, and we're going to get an actual numeric value for this. Let's see if we can do that. All right, so what we're going to do is we're going to get X bar is equal to, this here is equal to 36.27 plus this next section right here is equal to 0.4 plus this next section right here is equal to 2.46. And then if we add all that up together, we're going to get the number 39.13 atomic mass units. This is equal to the average, and that is our answer right there. Okay, and hopefully you got that. And what we're going to do is we're going to compare this with what's on our periodic table for potassium. We already found potassium earlier, but 39.13 is the average. And on our periodic table, I have 39.10. So this 39.10 and this 39.13 are very close to each other. So that's a good thing, and that's going to work very nicely for us. Perfect. I love it. You guys are doing a fantastic job. Hold on. And you're going to keep on going. We got 3 more problems yet to do. This next one here, it says number 2. Bromine is one of only 2 elements that is a liquid at standard conditions. Determine the average atomic mass of bromine. If there are only 2 naturally occurring isotopes of the element, when one isotope has a mass of 79 atomic mass units and an associated percent abundance of 53%, the other isotope has a mass of 81 atomic mass units and a percent of 47%. So average is equal to percent times mass plus percent times mass. Now this one is actually simpler than the first problem, but it's similar to the first problem. So what we're going to do is we're going to calculate the average, and that's X bar. Okay, we have 2 naturally occurring isotopes. We have a mass of 79 atomic mass units with 53%. That's one of them. The other one has a mass of 81 atomic mass units and a percent of 47%. Okay. And so what we're going to do is we're going to have our percentage of 53 over 100 times our 79 atomic mass units. I've kept the green sections together, the green numbers together, and then we have 47%. That's 47 divided by 100 times the 81 atomic mass units. Okay, Now, one thing that we want to look at here, and that is we should see and understand that the 53% plus the 47% is equal to 100%. That means I have all the isotopes available to me. And um, just like in the last problem, I had 93% plus 1% plus 6%. That's actually equal to 100%. You can't have more, you can't have less, you must have a total mass of all the compounds. That's 100%. Okay. So now we're going to do the little bit of math that's associated with this one here. So that is 53 divided by 100 times 79. That will equal 41.87 right there. And then it's the 47 divided by 100 times 81, and that will equal 38.07. Then what we're going to do is we're going to sum up these two numbers. That will be the average is equal to 79.94 atomic mass units. And this is our answer. This answer goes with bromine, right? Because this is the element bromine. Let's just do a double check and make sure that bromine, which we just discussed earlier in this worksheet, has a mass of approximately this number, an average mass. And here is bromine right there. It's 79.90 is the average, 79.94. That looks pretty good to me. Okay, perfect. They won't exactly match with what's on my periodic table because I am averaging, I'm using different numbers than what they came up with this particular periodic table, but that shouldn't be a problem. All right, let's move on to problem number 3 here. It says an element has two stable isotopes, Ga69, that's 69 atomic mass units, and Ga71, that's 71 atomic mass units, with respective abundances of 60 and 40%. Calculate the average atomic mass of this element. So I'm going to highlight here, 69 atomic mass units goes with 60%, and then 71 atomic mass units goes with 40%. You should see that whoa, look at that flying pin. 60% plus 40% is equal to 100%. That means I have all the isotopes in this element. So the average is equal to percent times mass plus percent times mass. All right, perfect. So the average is equal to percent. And let's see if we can do that here right now. Percent is 60 over 100. That will give us our decimal value. And its mass is 69 atomic mass units plus 40 divided by 100. That's 40% times 71 atomic mass units. Perfect. Looking good like that. So I'm going to key this into our calculator here. And that will be the following right here. The average is equal to 41.4 plus this one right here. And that is 28.4. So that's 60 divided by 100 times 69. That's 41.4. 40 divided by 100 times 71 is 28.4. We're going to add up the 41.4 and the 28.4, and we're going to equal 69.8. And 69.8, that should look pretty good right there. This is the average atomic mass units, and that is our average. And this is our answer for this. And this is the element Ga, which is gallium. So let's find that on our periodic table and see if that matches approximately as well. 69.8, that's for the element gallium, and that's 69.72. That's pretty good. Okay, it doesn't have to match exactly, but it's probably pretty close. That's what we're looking for. We have one more problem to do. Let's see if we can hammer that out. Okay, so let's slide this on up and do the last problem here. Let's slide this up here. All right, perfecto. All right, so this next one here is indium was named for its indigo blue line in its atomic line spectra. There are two naturally occurring isotopes. The mass of one is 113, and the associated percent is 4%. So let's highlight those two things together, 113 and 4%. And the mass of the other is 116 atomic mass units and 96%. What is the average? So we're solving for the average yet again here. Absolutely. Okay, so let's see if we can do this here. The average is equal to percent times mass plus percent times mass. So average is equal to percent, that is 4 divided by 100 times 113 atomic mass units plus 96 divided by 100 times 116 atomic mass units. I'll just note one thing here again, 4% plus 96% is equal to 100%. Yet again, that will always be consistent. All right, so let's see if we can do this. This is the 4 divided by 100 times 113. That will be 4.52 plus the 96 divided by 100 times 116. That's 111.36. So our average, we're going to sum up these two numbers here. As we sum up those two numbers, that will be 115.88 atomic mass units. This will be our answer. Yes, absolutely. That looks fantastic. And let's see if we can find indium on our periodic table, and it should be approximately within that range there of indium. And so indium is right here underneath gallium 114.82, and I got 115.88. So that sounds fantastic. So by the way, here, this is the last one here, but just I really appreciate it as you watch these videos through their entirety and to the end. That is hopefully helpful for your understanding of how to do the problems and mathematically solve them all out. This lower half was calculating the average percent abundance of a naturally occurring set of an isotope with all the naturally occurring isotopes, the average mass. All right, so hopefully that worked out well for you. Please like and subscribe. I greatly appreciate everything that you do, and thank you very much. And I'll see you next time. Bye for now.